Hi everybody, welcome back to another episode in the A to Z of Python. Today we're going to be talking about HTML scraping. To do that, we're going to use a tool called Beautiful Soup, which is awesome and easy to use. And to give you an idea what that means, let's take a look at this Wikipedia page here. And I'll zoom in a little bit. So we have the Billboard Top 100 singles for the year 2000. Let's say that you want to take just the actual song information and export that to a spreadsheet or a database or something like that. And maybe instead of just the year 2000, you want from 2000 to 2010 or some other date range. So it becomes tedious to like copy and paste these and try to format them when you can use Python to automate the entire process. So we're going to try and do that today. We'll actually use this as an example. So let's copy this URL here and get started. So to install Beautiful Soup, you can use whatever package manager that you have. I use pip, so just pip install Beautiful Soup 4, and there you go. So now we have that installed, let's do our imports. So Beautiful Soup 4 is BS4, import Beautiful Soup. We're going to use requests to fetch the HTML itself. So you're going to need to have that installed, one, and be familiar with it too. So if not, go back to the very first video in this series on APIs, and we cover requests in depth so you can kind of understand what's going on. And then we're also going to store everything in a list called data. So go ahead and initialize that. And let's get started by doing our request. So just like a standard request, r equals request.get, and we'll paste in our URL. And then if you remember, request will actually return sort of an object of the page itself and the header that's returned with it and all this other stuff. And we don't need any of that except for just the raw text itself. So we're just going to do text, and that's essentially just going to fetch the HTML of that, and we can do something with it. So Beautiful Soup will handle everything else. So we're going to do soup equals, this is a standard procedure here, and we'll put in our variable that contains the page that we want to work on, and specify an HTML parser, which in this case is just html.parser in the single quotes. And this is the standard built-in Python HTML parser. So it's going to take this page, which is returned by request, and parse it out into its individual components. So we're just going to try to see what this looks like by doing print soup.prettify. And if we run that, you can see essentially what we got back here is just the page source. Okay, so it's like everything that's contained in this page here, just in HTML. So we need to kind of zoom in. So maybe if we wanted the links, we could just specify the links. There's a bunch of methods in Beautiful Soup that we can call to kind of fetch just or filter or whatever we want to do. But we need to think of it like we want to zoom in. So we don't want to zoom in on the head or the body, whatever. We want to get pretty specific. So let's go to the page itself. Right-click in the table that we want to get the information from. And with Chrome, you can kind of hover over each element and see what it is and where it is on the page. So if we get down to here, this table is actually everything that we need is contained within this huge range of code here, okay? And so what we can do is we can tell Beautiful Soup to filter out everything except for just keep the table itself and everything that's nested within that. So let's give that a shot. So we'll name this table, and we'll do soup, which is referencing this here, .find, and we'll type table because it's a table that we're looking for. And there are multiple tables on here, okay? So if we just left it at that, we would get this table here, and this is probably a table, and that's a table. So we need to be more specific. So the class is called a wiki table sortable, which is over here on the right. It's maybe hard to see, but that's just the actual class type. So we're going to go in and pass an argument It's attributes equals, and it's going to be a dictionary, and it'll be class, and the value will be wiki table, which again we get right from here. Now this is, I know it's kind of hard to read, but it's wiki table sortable jQuery table sorter. That's the actual class type. By using wiki table here, it'll find anything that has that in the actual class description. So since there's only one table here that has that particular class description, we know we're only going to get this information back. So we can give that a shot. We'll print out table and see what we get. So now all the other HTML code is gone except for the table itself. So you see it starts here with the table, and then each row, there's the header row, there's row 1, row 2, and so on and so forth. So you'll see here that inside each row, we don't really want this first row, so we're going to skip that eventually, but we don't need this information. We know what this is. We want these rows, which has the song place on the Billboard chart, so that's top #1 song. And then we have a row that has the title, and then it has the artist. And this will be considered the text method, so .text, when we call that up. So keep that in mind. So if you see here in this row, we also have what looks like a header cell. So TH is a header cell, which is going to look like this. Okay, it's like it's shaded in gray. It's got a different style, and it's bolded. And then we have a regular cell with just the link and the description, and then we have another regular cell with the artist. So we need to zoom into the row level. So the way that we'll do that is we'll do rows equals table dot, instead of do find, so okay, we're going soup here, table here. Okay, so you're kind of zooming in one level at a time. So this is going to be table dot find all, and we're going to find each row. Okay, so we actually want to get each row. Now the way this works is find all is different than find. Find just kind of gives you this, the table variable will be everything in this class, which you see here. So this is like one just gigantic variable that holds all this information. Find all returns a list. Okay, so it's going to return a list of each row is going to be its own particular item in the list. Okay, so each one will be indexed. And I can show you what that looks like. So let's do for row in rows print row. Maybe try that out and see what happens. All right. So now you can see that the class for the table's gone, and we just have one row here, and like I said, we don't want this first row. So we can tell Python to skip that by just specifying a range of 1 onward. And if we run that again, hopefully, yeah, that's gone. There you go. So now we've zoomed into the row level of this particular table, and we've skipped past the sort of header row here, which we don't want, and we've gotten right into the meat of everything, which is just going to be one song after another. And you can see that here. So great, so that looks good. So what we're going to do now, so let's go and zoom in even further into the sort of cells themselves. We're going to go to each column. So we're going to do calls equals row dot find all again. So we use find all again because we want another iterable list. And so this will zoom into here, if that makes any sense. So, you know, we've gone from the actual page to the table to the rows themselves into the columns, which is just this highlighted data here. And you see there's a TH tag and a TD tag. So we need to find both of them, okay? Because we want it to return all of this. So inside of here, what we'll do is we'll actually use a list, and we'll do T, D, and TH. So you can pass lists in to Beautiful Soup just like you would an individual item here. Just don't forget to use your brackets. And then let's try to print calls. Let's see what happens. I don't know if that'll work, but we'll give it a shot. Okay, there you go. So you see how it's kind of streamlining it? So this is one song after another, and that's great. But we don't need all this HTML. We just really want the text inside of that. So let's do for column in columns print call.text. And this is a function of Beautiful Soup that will extract the text out. And there you go. So now we have this great looking output here. Top song, Breathe, Faith Hill. Santana was tearing it up too. Okay, so everything looks good. What I'm going to do is I'm going to manipulate this using list comprehension to put each one of these items into its own list. Okay, so it's going to look something like this. And then we'll add it to the actual data list too. So let's do data.append. Okay, so let's write this information in. And it's going to get a little fancy here. We're going to create a list, and then we're going to do call.text for column and columns. And hopefully you understand what's going on here. If not, you can kind of look up list comprehension and see what we're doing here. But we're going to end up with this here is going to end up putting each one of these. Okay, so each set of information in its own list. So let's print data once that's done, and there you go. So you can see it's a list of lists. We can even do for song and data print song, and that's probably the best looking format. There you go. So you can see that we have everything that we need. And we could write this to a CSV as it is. Okay, we could just put the CSV output right here. So that's it for scraping one page, and that's enough information. You can stop now. But what I would like to do is go ahead and grow this into a function that can scan over a range of years and can also export to CSV to kind of wrap it all up. So if you want to see the extra detail, just keep watching and we'll go ahead and get started on that now. So let's create a function first of all called scrape data. We're going to pass it the search year, and that'll just be the year, and we'll run a loop so it'll pass it a bunch of years, and we'll save each year's worth of data in something called year data. Okay, so this year data will be essentially this. So whatever we see here will get passed back, and it'll be a bunch of years stacked in. And then what we're going to do is we're going to construct the URL for request manually. So the URL equals, and we'll steal this. And get rid of the year. And add in search year. And let's make this a string. And I think we can change this to URL. Okay, so if this makes sense, we're going to pass in a year, like say 2010, and we're going to take this and we're going to append the string version of 2010 onto this, and that will create the URL for the correct page. And if you were to click through the Wikipedia pages, you would see that the URL up here is actually the same for each year. It just changes the number on the end. So that's how we can get away with that. We just change the search year variable up one at a time, and it'll get the next page. Okay, so that looks good there. And then let's actually take this information here and move it up. And what else? Let's see. yeah, we'll take this information here and move it over. So we're kind of reusing a lot of the information here. Basically, it's going to look pretty much the same, except this data.append is going to be year data.append. Okay, so we're going to save it to its own separate file, or excuse me, own separate variable. And then what I would like to do is, since we're going to have multiple years, it'd be nice to have at the beginning of our list, to the first item in the list to be the year itself. So it's kind of like prepend the year on there. And that's going to look like for in year data in.insert 0 search year. And then we'll return year data. So to clarify this one, it's going to iterate through the entire year's data here. And in the very first index, which would be sort of like the spot here, 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 and here, all the way down, it's going to insert the year. All right. And so we'll end up with, say, 2010, song number 1, Breathe, Faith Hill, so on and so forth. So we can kind of, like when we import it into Excel, we can sort by year, filter by year, and that's pretty helpful. So let's actually, this function should work. So let's give it a shot. Let's do it for a range of years. So we'll do for year and range. Let's do 2000 to 2010. And we're going to do a little bit of error or exception handling. So we're going to try data.append. And we'll call our function, and we'll pass in the year, and we'll give some kind of screen output here. So it lets the user know, like in the window here, that we're actually doing something. And let's see, we need to have an exception. So what's going to happen is if we go beyond the year, like say we go to like 2017 and it doesn't exist, it's going to throw an exception, because request or one of these functions, like our for loop or whatever, is going to blow up and say either the page doesn't exist or the table that we're looking for with all the top songs doesn't exist. So we're going to get an exception. So we need to handle that. And I found just through testing that it's called an attribute error exception that we get when we go beyond the page, like we go too far. So like if they only have data to 2015 and we try to run it for 2016, we're going to get an attribute error exception. And so we're going to handle that. And we'll say, I don't know, print, like just give them something. So we'll say year, and I'll say doesn't have the data you're looking for. I'll put stopping, something like that. So whenever it goes beyond the scope of what's available, it'll stop the program with the break, and it'll tell the user that we can't go any further. And let's see, we'll get rid of this. So this should work. I don't know, let's give it a shot. We'll run it and see what happens. So it appears to be scraping data, and it exited with no problems. So that's great. So let's do, okay, so everything's being saved in this year data, and then it's being appended each year one at a time. It's being appended to the actual data list. So let's do for years in data, and we'll do for songs in years, print songs. Let's try that. All right. So there you go. So that's looking pretty good. So every song from our range here, so it's going to be 2000 and it'll end at 2009. That's just the way Python works. So like 900 songs. So it's working the way we hoped it would. So let's go to the last step here, write this to a CSV file. So it'll be writer equals csv.writer open, and let's name this songs.csv, and open it for writing. And we have to specify the delimiter of the comma and a line terminator of n for the carriage return. Let's see, where's that at? N. And the quote character, because there are quotes in this, equals that. There we go. And instead of printing, we'll just do writer.write row songs and give this a shot. All right, so let's see here. If we back out of the presentation mode, and there's the songs.csv. Let's show that in Explorer, and open in Excel, and there you go. Pretty good. All right, everything you need right there. And just to show you that the exception handling works, let's go back to presentation mode, and we'll run this, let's say to 2020. Any number, doesn't matter, any huge number. You can put 3,000 there, doesn't matter. And run it. There you go. So it looks like the data stops at 2015, so there's no top charts for 2016 yet. And it handles it beautifully, exits out, and again, if we go in here, tons and tons of songs. Everything you need, and that's it. It's pretty much how it works. Now, the only other thing I'll tell you is you have to be careful when you're looking at Wikipedia, because sometimes if you go way back, like let's say you wanted to pull songs from like 1951, that doesn't look too bad. But I know, like for example, in movies, for example, there's some formatting problems. They don't always use the same formatting from year to year, and you can kind of get errors kicked back. Or blank, variables here. So you'll have to get more creative with how you sort and overcome missing information or information that changes over time. So this is a pretty easy example, but it's good enough to get you started. So hopefully that helps you out. If you have any questions, leave a comment, and I'll be happy to help you. Otherwise, thanks a lot, and I appreciate you joining.